I'm really grateful to Leo for joining us today. We haven't actually met in person, but we've kind of been interacting on Slack and on Twitter for the past few months. And yeah, from what I've seen, Leo is really an amazing force for pursuing and helping to actually engage with communities and getting them to change and take on really good practices and provoking this discussion on the environment and sustainability, which is really important. And he's also giving a session where he's really involved with leading the session that's happening at EAS 2020. And I think also largely because of him, EAS 2020 is actually still going ahead as a virtual event. So we have, yeah, thank you so much for joining, really.
Well, thank you. I don't want to take credit for all of that, but perhaps I'll just start before it gets embarrassing. Okay, so thank you very much for having me here. Let me start by sharing my desktop, and then moving here to full screen. All right. If you do not see the famous Earthrise picture now, then please tell me. But normally it does work. So yeah, thanks a lot for joining this talk. My name is Leo Burtscher. Thanks for the thumbs up, Dan. Most of my work is actually these days about METIS, the mid-infrared imager and spectrograph for the ELT, where I'm the calibration scientist, but I'm also a staff member in Leiden. My research is mostly about active galactic nuclei, where I study high resolution, where I use high resolution methods to study the very center. So AO methods, but also VLTI to study the torus. That of course doesn't exist in this way, but that's a different discussion. All right, so here, this is going to be about a relatively new group that formed about a year ago, started independently in the US, in California, and at the last EAS meeting, which was at that time so-called EWAS meeting in Lyon last year in June. And this group is called Astronomers for Planet Earth. Hannah is also part of them. And you can view our webpage at astronomersforplanet.earth. Didn't know that that subdomain exists by then, but okay, that's great. We're also very active on Twitter. And one of our members is really good in producing really great videos. You can check them out on Twitter. All right. So this picture is will become clear in a second and less pixelated. So as we're looking to this crisis, right, to the Corona crisis, and trying to flatten the peak, some people say that the real crisis is actually just still ahead of us, the climate crisis, which is so big, but still not really visible. It's like perhaps if you want to compare it to the first cases happening in Italy in February, March, where everyone thought, oh, it's too bad that it's happening there, but it's not going to be a problem for us. And then it became clear so quickly that it's really a massive problem. And then everyone reacted, fortunately. But with the climate crisis, we're still in this phase where it's beginning to become obvious, but it's not yet such a major problem that everyone is on board. And that's why it's so important to talk about it. So there is this really good animation here that shows the carbon bucket. And that's essentially all the carbon that we can emit, that we can put into the CO2, that we can put into the Earth's atmosphere, CO2 and CO2 equivalents like methane and others, to not get more than 1.5 degrees change. And you can see how that has been increasing ever more rapidly in the last years. And so by 2019, which is already a year ago, there was only a very little bit left. And if you want to have this more scientifically, then you can look at graphs like these, and you can see that the longer we're going to wait with reaching peak CO2 emissions, the more drastic this reduction has to happen. And that, of course, it's already very challenging now. So as of 2020, we need a reduction of about 7 to 8% per year to reach, to not overshoot this carbon budget. And every year we wait, of course, this reduction needs to be ever more drastic and ever more unrealistic, one has to say. This is all assuming that we're not finding some magical way to eat up carbon in a massive way, which so far there is no technical solution for this. But this is a different discussion. All right, so then the question here in this talk is really, what can astronomers do about this? So I guess many of us see all these reports in various newspapers, and we wonder, okay, we're studying whatever stars, exoplanets, galaxies, all of the wonders of the universe. how can we, with a good conscience, do that and keep doing that while there are all these troubles around us? And I think it's very important for us to keep doing that, to keep doing astronomy, which is of course one of the most fascinating things that humankind can do. And we can actually contribute to solving this problem. And I think in two ways, but perhaps we can discuss more ways. So one is we can lead by example, and we can reduce our own carbon emissions. And I think we're in a very good position to do that because we're very international. So if we can do that, then other, let's say, big corporations who are also international can do that as well. We can show how global collaboration can work without too much hot air. And we're doing this, of course, right now, right, by having this video chat here. But then, and that's perhaps even more important, we can, with our outreach capabilities, which many of us are very active in, we can reach a very wide population, and we're in kind of a neutral stand ground. So if climate researchers give outreach talks, they're often confronted with, oh, but you're paid by whatever, the left government or who knows what. But we are, we're just studying the universe, and we're seen as authentic scientists by many who bring, the best picture of, or the first picture of a black hole or a new Earth-like star. And that's just so amazing, and people trust us in that. And we can build on that and use that reach that we have to also convey a special astronomical perspective and make clear why it is so important to preserve Earth. So let's first talk about our own carbon footprint, and then we come to the more outreach part. This is something that has only really started in the last years. And actually, I know of only 3 initiatives where institutions have tried to assess systematically their own carbon footprint. One is the Max Planck Institute for Astronomy in Heidelberg, where this is basically done by Knut Janke, who is very active in the sustainability group there. And then the second one will be by ESO, the European Southern Observatory. And the third one is by the Canada, France, Hawaii telescope, CFHT, which is not yet public in any way, so I can only mention that they are doing this. They will talk at this ES 2020 meeting that Hannah mentioned in the beginning. So for the MPAA, which is a research institute in Heidelberg, and by the way, where I did my PhD work, they have about 350 or so people working there, from everyone combined, from students to staff to engineers. And I would say they're a pretty normal, I mean, of course, they're an excellent institute, but they're an average institute in the sense that their activities are perhaps representative of, for example, also what Leiden is doing. Not quite sure I know the ARI in Manchester well enough to say if it's comparable, but perhaps you can tell me. So they did this analysis, and they found that, perhaps not too surprisingly, a large factor, a large fraction of the CO2 emission from their institute comes from flying. And actually most of the flights are long distance flights. So that's mostly MPAA involved in the LBT in Arizona, and of course also in various instruments, telescopes in Chile. So it's mostly these intercontinental flights. So whether they take the flight from Heidelberg close to Frankfurt to Berlin, or the train, is kind of nice to go to the train, but that doesn't really matter in that budget. A second big point, and that's perhaps surprising for many, is the electricity consumption on site, which will be replaced by solar in the next years, thanks to the activities of this group. But then also off-site, and it's actually even more. You can see here 441 tons in 2018 for electricity production at supercomputing centers. And this is still relatively low for this institute because they use the local, their local energy provider, Stadtwerke Heidelberg it's called, who tried to make a point in being a very green utility. The average German CO2 intensity per kilowatt hour is actually much worse because in Germany there's still a lot of coal power. And then there comes heating and commuting and a few other things. And so, yeah, so this is 300 employees, and you can compare this and find that it's about 9 tons of CO2 equivalents, which includes meat by the canteen, but that's actually not very much per employee. You can also break it down into tons of CO2 emission per article, if you like, and then it's a little less than 5 tons per article. So then you can wonder, okay, is that a lot or not? You might want to compare it to the average CO2 emission of developing countries, where we're talking about something like 1 to 2 tons of CO2 equivalents per year per person, and then perhaps 5 tons per paper is quite something. But okay, so these are the numbers for MPAA. Yeah, and that's the comparison for Germany and for India. And then a second calibration point, let's say, is ESO. They did the most complete carbon assessment, let's say, that you can do. They did a full carbon audit by a company called Carbone 4. It's a French company that was built up by climate researchers, actually. So they, I think they know what they're doing, and they are really differentiating between the different origins of the CO2 emissions. So this is called scopes 1, 2, and 3, depending on whether the CO2 emissions are produced in the so-called upstream activities, so in things that go into the company, or in the downstream activities, let's say an iPhone that is produced and then produces CO2 emissions due to being charged later on, and then the company activities themselves. For ESO, of course, this is mostly upstream and the company or the observatory activities themselves, because we don't produce, I mean, at least no material things that would use more energy. But this already tells you or shows you that there's a big, say, a big effort of accountancy behind this if you want to do this completely with taking into account all the purchases and stuff that goes into the company. So this is the carbon footprint that they computed then. It's quite a bit different than the one for MPAA. I think it's interesting to contrast these 2 points. So for ESO, the biggest factor is energy, and that's actually energy use at Paranal mostly. So 52% Paranal, something 13% in La Silla, the older observatory, and 22% in Garching, and some other smaller contributions. And this is really because Paranal, at least until recently, I think still, they're using gas turbines to produce their CO2. For ALMA, which is not included in this analysis, by the way, is actually even worse. They have LPG, liquids pressurized gas, transported to their site every day. And since this comes from far away, like 1,000 kilometers or so, they really come from, I think, Santiago, or they go all through Chile, essentially, or through a large part of Chile, and transport this LPG every day with a truck. So that is even worse. It is being improved now by having gas lines as well. But okay, so this tells you that for an observatory, energy use is actually the biggest factor for the carbon emissions that needs to be tackled. And the second big factor is purchases. This is all stuff that is being bought. So the computers, other equipment, I think it's actually split out here, maintenance stuff. So it's also important to look at your supplying companies and ask them to have a watch on that. Right, and then there's travel, which is actually a surprisingly small factor for ESO, perhaps because they operate very large telescopes compared to the size of the institute themselves. And again, the biggest factor, which is of course clear for ESO, is long-haul intercontinental travel between Europe and Chile. All right, this will actually be, there will actually be more on this, unfortunately not from ESO themselves. Should have removed this here. They're not yet ready to talk about this in more public spaces, but there will be more from MPAA and from the CFHD observatory at the ES session. Okay, so what can we conclude from these 2 points, from these 2 calibration points of our own carbon budget? Well, I think first of all, we need to first understand our own carbon footprint before we can reasonably suggest changes. So that's an important effort, so that you're not, for example, if you try now to start replacing all your national flights by train travel, which is good. I mean, I'm doing this for everywhere in Europe. I try to go by train, and also I just like to go by train, but that doesn't really make a huge difference in the big picture, right? So it's important to keep the big picture in mind. And the other thing that I would like to take you away from this is that understanding the whole carbon footprint, including all the upstream activities with things that are being purchased and coming in, is really a research project in itself. So this company, Carbone 4, spent months in analyzing ESO's carbon footprint, and the report that they produced, which I have seen, is I think almost 100 pages thick in describing exactly where all the emissions are coming from. But okay, there are some low-hanging fruit like electricity, which can be replaced in many cases with green sources, and some travel that can at least be replaced with video chats. Okay, yeah, and this is the third point here. There are limits to what you can do as an individual. So it's very good if you say, okay, I don't want to eat too much or not at all meat. I want to go more by train instead of plane. That's all very good, but that only has a relatively limited action. And actually the Corona crisis is showing us how limited that action is. There has been research showing that this year, the CO2 emissions will probably fall 7–8% compared to 2019. And this is because everyone has essentially stopped flying for several weeks, and also to a large part stopped using the car because we don't have to commute anymore and cannot see anyone. And that is only 7 or 8%. So that shows you that there is much more that needs to happen, and that you cannot ask yourself or your neighbor to do, but that's something that we as a whole community must do all together. All right, and then this brings me to the second point, whether there is more that we can do as astronomers, and I think there's actually an even more important contribution that we can deliver as astronomers, and this is outreach in terms, or let's say including climate communication into our outreach. So one part, for example, that we can convey to the general public as facts. We're very good at storytelling, very good at reporting about astronomical facts, and we can weave in some climate facts into this. For example, there are some people still who believe, oh, well, climate change isn't anthropogenic at all. It has always happened. It's the sun. It's something else. Well, okay, we can show some facts. For example, here we can measure the total solar irradiance. For the older years, this is based on the solar sunspot number that has actually been determined since Galileo, 1609. And that shows the 11-year solar cycle. And it also shows there are some variations of the solar activity, but it cannot explain, by far not explain, the temperature anomaly that we were seeing since the 1960s. A second thing that we can do is we can explain methods. We can explain scientific methods, although they're not our own methods, but they're in some sense still very similar methods. I mean, if we're whatever high redshift researchers, or just if we want to measure gas in the universe, right? We try to measure the molecular gas in the universe, and we're not doing this using measuring the H2 lines normally because they're very hard to measure, but we use CO, so that's the proxy. And that's the same that's happening in climate research. People use proxies to reconstruct the temperature record of the Earth. For example, they use the differential oxygen isotope measurement, which works in a way that the heavier oxygen 18 is found more easily in the ice phase of water. So since it's a heavier atom, it gets more easily buried or locked up in ice compared to the normal oxygen 16. And that variation in oxygen in ice cores, for example, that are drilled up from the Antarctic or from Greenland here, or from Russia, that can be used to reconstruct the past Earth climate. And this is, for example, how people confirmed the cycle of glacial and interglacial periods, so the so-called 100 kiloyear cycle over the last million years or so, where we had always this change between ice ages and warmer interglacials, which probably comes actually from an astronomical factor, namely the inclination of the Earth orbit around the sun. So that's an interesting topic by itself, but it has nothing to do with what we're seeing right now. Right? This is on much longer timescales. So this is one proxy, the oxygen proxy. There's also the proxy. Sorry, this is missing a label. This is the proxy of the wood or tree rings, which in warmer years trees grow more. So there's also anomalies there in how trees grow, and from that you can also derive a temperature anomaly over many years. And so yeah, you can explain these proxies, read up. I mean, this is just normal scientific literature that is actually very accessible. And these can all be compiled, and this is a nice compilation made for the Global Warming Art project, where they compiled I think 11 different proxies for the Earth temperature record, and show that they're actually, well, not fully consistent, of course, although perhaps from an astronomical term one would say they're consistent. And there's always, of course, this extreme rise, which is actually more than 1 degree by now, by 2020. So yeah, this is, I think, one aspect, again, that we can contribute. But then on a more philosophical point, perhaps what we can also contribute is the perspective. So our special astronomical viewpoint of saying we're not just here on Earth, but we know that there's something around us, right? We know that we can view Earth as a planet. For example, here as seen in this famous Earthrise picture, which was named the most influential environmental picture of the 1960s. And that has been taken, of course, by the Apollo 8 astronauts as they circled around the moon, and then Earth just rose behind the moon, and they saw the Earth as a marble in space. Of course, there's even more distant pictures of the Earth, like this very famous pale blue dot picture that I'm sure you know. Here's Earth, about 0.2 pixels large, as seen from behind Neptune. And that just shows the vastness of space and how little the Earth actually is there, and how isolated really we are, and that there's nothing around us, and we're really all in this together. So there's no point in discussing about, you know, in finding too many differences between all of us. Let's rather work together to make this tiny spot a livable place for us and for the next generations. So I think this is a viewpoint that I think we can bring, and I'm sure you had this experience yourself when you talk with people and you show them these pictures, that they're really, this is really amazing, and it really opens the perspective and brings into perspective the problems that we have in everyday life compared to what really matters. There's more that we can do as astronomers. We can, of course, bring in some exoplanet research. We can tell people that, of course, yeah, there are many planets known to date. Apologies. More than 4,000 actually. And although people often talk about, oh, let's find this planet B, I think it's actually not a good thing to say. We should rather say, let's find an Earth analog. There is actually no planet B, right? Even if there was a second planet that might be like Earth with liquid water and a benign atmosphere and potentially some more or less intelligent beings on it, it would not be Earth. It would be so far away that probably none of us, well, certainly none of us could ever go there. And even in the far future, not all of us could move there, but perhaps very few people with a very expensive, complicated mission. So I think that's important also to frame the mind rightly, to say, okay, there are, of course, lots of planets, but we don't actually know, and there's no chance really to finding a second Earth. So we really need to protect our own. And then, of course, there's just, in general, astronomical pictures that are always really amazing for everyone, like this really fancy picture of the Milky Way from the VLT with the laser from UT4 shining into the galactic center. Where you just look at this and you're just overwhelmed by the beauty of the night sky. And there's actually some psychological research that shows that what I wrote here as a title, that awe triggers empathy. So if people see something that is particularly beautiful or particularly inspiring, you can reach them better in asking for their humankind and asking for, well, asking them to be peaceful and to be, let's say, better human beings. So there is some value in that for looking at astronomical pictures. All right, this brings me more or less to the end of this part. Now I just wanted to highlight a few activities that are going on within the European Astronomical Society that perhaps some of you would like to get involved as well. So as has been mentioned a couple of times already, there's the ES 2020 meeting, which was actually, we actually planned it to be a green conference to, well, have not quite a carbon neutral conference, but at least try to minimize emissions as far as possible. This is now, of course, very different. We're now an online meeting, as of course everything is going online these days, but it's actually already a big success. We have almost 1,500 participants already, and it's going to be the largest astronomy online conference to date. So the WS 236 meeting a few weeks ago had, I think, just over 1,000 participants, which of course is also really great, but it was just their summer meeting, which is a bit smaller. And we have an even bigger meeting with almost 60 sessions and lots of things going on. The meeting will also be not very expensive, 80 euros for the whole week. And that's, well, that's again, deliberate to make it as accessible as possible for everyone, students, people from poorer countries, so that everyone can join. And we have this full day series of sessions, special sessions and lunch sessions on essentially this topic, astronomy for future, with all sorts of really interesting talks, including some very big names like Evine van Dishoek, who is the IAU president, and Sir Martin Rees is talking about the future of humanity. So we have some interesting talks there. So if you haven't registered yet for the conference, perhaps I can find some 30 extra participants thanks to this meeting. All right, and then there will also be a new working group on sustainability by the EAS, the European Astronomical Society, that is being formed at this meeting. And if you wanted to contribute there, you're very welcome. Okay, that brings me to my last slide. I'm just pointing out some more resources in case you want to read more about astronomy and the climate crisis. So for Astronomers of Planet Earth, we have a mailing list and a Slack space where actually quite a lot is happening. We also have a Google Drive with all sorts of resources. We have regular video meetings every month or so where we discuss about various ongoing projects. And then there are some publications already online, so white papers written by different communities, by the American Astronomical Society community, by the Canadians, and by the Australians. They already have white papers on this topic, and they're quite interesting to read if you want to know more about this. Okay, that brings me to the end of my slides, but I'm very curious to hear now from you what you think about it. Thank you.
Okay, well, thanks very much for that. So I'll try to moderate the discussion here a little bit. So if you'd like to ask a question or share some thoughts or otherwise, you can use the reactions tab, and I'll try to call on you to give you a chance to speak in an organized way.
I read in the preparation for this talk a little bit about your university, which claims they're using 100% sustainable renewable energy for their electricity, which is good.
Okay, so I think Steve has a question.
Yeah, it's me. I had to log out. I had internet trouble, so I'm back to being Astrophysics Research Institute. Okay, so you mentioned that. I guess it's the most obvious question. So just taking trains and things only makes a small dent. So what is the single thing that astrophysics departments can do that will make the most difference?
Well, I think as a department, I mean, essentially, I think we should attack this question in two ways. I mean, one thing is to become, let's say, green leaders ourselves, in order to show to people that we take this seriously, and to be also, let's say, convincing when we talk about this. And in doing so, of course, we need to replace flights by video conferences. We need to produce our energy with sustainable sources. So all of these things are important, of course. I mean, it's just not that one individual flight will make a change, but if you as an institute say, okay, we want to reduce our carbon output by, I don't know, 7% per year from now, I think that would be a very strong signal that would be seen by other, not just astronomy, but by other research institutes. But then even if we do this as an astronomy community, then it's just our community, of course, that's doing this. So I think we also need and we can push the general society to do more by using our outreach capabilities and telling people about Earth and how special this place is. Would you agree with this, Steve?
Yeah, so yeah, I'm trying not to barge in case someone else has a question. Yeah, no, I think that's good. I was wondering, so the energy consumption of ESO and things like ALMA, I mean, are there plans for, I mean, we could be trying to push observatories that, you know, making sure they're using renewable energy. I mean, I guess that I thought that's where you might be going when you said that. Are there plans afoot to do that? I mean, I imagine that could make a huge difference.
There are some plans, yes. I mean, for Lucia, for example, you might have seen, it was already a few years ago, they're building, or they have built, a solar power plant at the observatory. And this solar power plant is actually producing more energy than the observatory is using. Of course, it's only producing that a day, but they're feeding it into the grid and then taking back, for example, water power and wind energy in the nighttime. And on Paranal, there were plans to go to green electricity. I'm not sure what the plans are at the moment for the ELT, which will use about twice as much energy than all the Paranal telescopes combined. They're thinking of building a solar power plant, but this is of course still to come. But yeah, so there are definitely plans. I also heard that the new ESO DG, Xavier Barcons, is very much in favor of being more active there. So I think anyone of you who has contact with him or some other decision makers at ESO pushing the topic is, I think, also a way to leave really some impact. And there are lots of things going on. So they made this carbon audit not just to take note of what they have, but to really become active and see where they can make the most difference. So yeah, ESO I think is well on track, but yeah, there's still a lot of institutes that can be convinced to do more.
Thanks.
Yeah, Phil?
Okay, I need to be careful here as director of the Institute not to be picking on any part of our activities here, but one thing which you didn't mention very much, and I think I saw highlighted, wasn't there an analysis of the Australian astronomy that was published a few weeks or months ago? And a big issue there was computing that uses, to me, an unfeasibly huge amount of electricity. I don't know. I guess all we do there is just make sure that the energy generation is as environmentally sound as possible. Is there anything else we can do there?
Yeah, I think that's the most important part. So in the, just share this table here again. So in the MPIA study, they did compute this, and essentially the supercomputing activities are summarized here at electricity offsite.
Okay.
So that is essentially the supercomputing stuff, and you can see it's larger than the electricity consumption on site, which is mostly just running your personal computer, lights, well, the kitchen, these things, elevators. So it is a large part. It's, say, about a bit more than half of these 30%. So I don't know, say perhaps 18% or something. Yeah, I mean that indeed should move to green power. And I mean there are certainly ways to do that. I mean Apple, for example, and also Google, or some big companies, I think even Facebook and Twitter are quite active in that themselves. Microsoft recently announced that they want to become the first carbon negative company, in the sense that they want to not just be carbon neutral, but also take away through compensation measures all the carbon that the company has produced in the past history of existence of their company. So there are these activities that are going on. I think they just need to be pushed even more, and yeah, and we just need to be much faster. I think that is perhaps the most, if you take one message away, I think the most important message is really this, that there is of course lots of things going on in terms of green supercomputing is a topic, in terms of video conferencing, using the trains, even for larger connections. That is all there, and that will all become even more, let's say, available, accessible in the future. But it needs to happen much faster still. Right? At the moment, we're still on course for something like 3 degrees of warming. And that is just way too much. That is really risky, because we don't really know what's happening with the Earth atmosphere at 3 degrees warming. And we really need to limit it to less than 2 degrees. And for that, all these activities are there. We know how to solve it. In contrast to the Corona crisis, we kind of have the vaccine. We just need to apply it, and much more rapidly.
Dave?
there are people on here from the LT group, is that right? I just wanted to ask if anyone knows if there's been an energy audit or a carbon audit of the LT operation.
I understand that's the case. Yes, there's been one of the design aspects of the NRT is energy use and reducing that. Certainly, one of the aspects of the sort of work that's gone into planning the NRT. I'm not sure how high a priority it is, though. It does occur to me. This is probably a question for or something to put to Phil. Is this not an opportunity to sort of produce the world's first green telescope or a green design telescope, something where that's been more to the forefront in its design than possibly we would have done otherwise?
That's a very good suggestion. And well, you know, this is a very active stage of the development of the new telescope project. So yes, I'm sure it's already being included, but we can forefront it still further. So yeah.
One of the issues perhaps that is also worth mentioning here is that most people, at least that's my experience, most people with whom I've talked about this are actually in the astronomy community, are actually very much in favor of doing much more, right? Of going to green energy, of going by train, and all of these things. Actually, there's not a lot of resistance against going greener. The problem often is that if you want to have this institutional change, like you suggested, David and Andrzej, for changing, for example, the operations of this telescope, then it needs a lot of effort, right? Someone needs to do it, and it typically comes on top of all the things that someone who's already involved in this and already committed over the top of their head needs to do. So I think it would be very good if we could perhaps start to free some resources to support this transition. I'm not sure if we need a separate person employed for all of that, but at least make clear that this is really a massive effort that we need to do, and give, I don't know, 20–30% of time for some telescope engineer or for someone who wants to do that to say, okay, let's find a way to just capture the low-hanging fruit first and see what can we actually do.
Okay, there's a couple more questions. Robert first.
Hi, sorry, I should say I'm something of an interloper because I'm not at ARI or connected with it, but Hannah invited me, and I'm very grateful that you're entertaining me on the call. I'm from the Royal Astronomical Society, and we're just getting going in this area as well. We set up our own sustainability group actually last month, and Hannah is a member of that. So my question was, I mean, it's really heartening to see this. Did you find any? I know you mentioned that most astronomers are on board with this, but did you find any resistance when it comes to certain aspects of personal behavior? Because I often find that the main thing when this conversation comes up is particularly around areas like travel, and you rightly make the point that there are other major factors to consider, but it's still one of them. And to kind of affect that sort of paradigm shift seems a real challenge.
There is, in my experience at least, there is little expressed resistance against this, but there is some indirect resistance that people try to find all sorts of excuses why it is really necessary for them to fly to East Asia tomorrow to give a talk. One thing perhaps that is important to keep in mind is, of course, it should be especially important for younger people actually to move around, for PhD students and young postdocs to move around the world to build up their network. But these are actually not the people who cause the most emissions. This was highlighted in the report from the Australian astronomical community, that the more senior people are, the more flight-related emissions they produce. Because I mean, I don't want to blame anyone, but of course they really just enjoy being invited to conferences in the US and on Hawaii and somewhere else. And I mean, that is of course nice. I can understand this. And the message that I'm trying to give is that we don't need to stop this altogether. We should apply what, for example, in animal test, in the animal test business has been called the 3R rule. So that's reduce, refine, and replace. So we can continue flying, but we should just reduce it drastically. We don't need to fly for such a talk. I don't need to fly to Liverpool. We can do this via Zoom. For observing 3 hours at the VLT, I don't have to fly to Chile, like I did actually many times in my PhD. And it's totally stupid from the perspective now. But this is still happening, right? If you have 2 hours of GTO time at the VLTI, which are complicated observations, of course, then you need to fly there. So all these things can be changed, and we can reduce it to the travel that is really necessary. Like if you want to spend a month in Japan to visit your collaborator and work together with her, that's a very good thing to do. And I think we should reserve our carbon budget, which is not very big anymore, as you know, for these really important visits, and reduce it for things that are just an hour conversation. But yeah, I mean, there is definitely some resistance, but I think it can be broken partly by saying we're not trying to avoid, we're not trying to you know, to totally reduce, or sorry, to totally make it impossible to fly. We're just trying to reduce it. I think that's a better angle to go to it. To not say you cannot do it at all anymore. We just need to reduce it, and then you open the door for discussion.
You're right. So I'm sure many people have thoughts on this. We have a couple more hands up during this discussion. So I don't remember who was first. Aaron had some trouble finding the button, but okay, Trisha was first. So Trisha, go ahead.
Hi. On a slightly different tack, I have 2 questions. The first one is that I wondered if any work had been done on our university's investment programs in terms of the degree to which they might be investing in the carbon industries and things like this, where that money is flowing. Seems to me something that might not be so obvious, but that could be all tangled up. And the second one, on slightly a different note, on outreach, I wondered, is there a way to maybe pull together some resources that those of us who wanted to go out into the community and do talks, that we could have maybe some template information, some frequently asked questions, that would make it a little bit easier for us, since we're not climate scientists, to put something together and go out there.
Yeah. Thank you. These are both excellent points. So on the first one, what's called divestment, right? So to go away from all our investments into fossil companies, that is indeed a very, very big topic. And you might have seen the report a week ago or so, where there was a big discussion in Stanford, for the Stanford University, where the students and I think also staff tried to convince them to divest, to move away from investments in fossil fuel companies. But the Senate, which is composed of scientists, of professors, voted against it. Because for them it was still more important to have, well, I don't know, some slightly better return than, well, thinking about environmental friendly businesses. So I fully agree. This is a very important point, and I think this is really a big topic. I should have mentioned it, and we'll actually add it to the presentation for the next time. This is a really big topic. On the second point, I'm blanking. Regarding presentations.
Yeah.
Yeah, got it again. Thanks. This is actually one reason why Astronomers for Planet Earth have been set up. So if you check out the webpage, astronomersforplanet.earth, you don't find, I think at least not yet, public templates that you could download and use for outreach. But this is definitely something that we plan to do. And if you want to join the group, I mean, that essentially just means signing up for the mailing list at the moment, then you'll get access to a groups.io account, which we have, where there are some, where there is some material. There are some presentations, like, for example, this presentation that I just gave, I put on there, or I think it's on our Google Drive, or it's somewhere there, and you can download that to have some collection of slides. But yeah, I think this is an excellent point that we should do more. And of course, if you know anyone who has slides, or which slides we should include into such a collection, then let us know.
Thanks. Thank you very much.
Okay, Aaron?
Yeah, hi. I was wondering if you've spoken at all or considered speaking with, for example, native populations. I'm just thinking, say, I'm sure it wouldn't be too hard to find a native Hawaiian activist who would argue that the best way we could reduce our carbon footprint is by you know, halting construction and or clearing sacred mountaintops. Has that been anything that you've thought about?
This is, yeah, that's a very big topic by itself. It's not something that I have thought about so deeply because I'm really coming more from the, well, let's say continental European perspective where, let's say conflicts with the native population don't exist in that case so much. So this is not something that has been so much in my attention. But, and I was first when you started mentioning this, I was actually thinking more of Native Americans through whose territories they're, for example, planning to build this Keystone XL pipeline, and they're rebelling against this, and they need to be supported in this, of course. Regarding construction of telescopes, again, from the European perspective, I mean, the ELT is built on a mountain in the Atacama Desert, which, as far as I know, has no meaning for any native population there. Well, that's of course partly because the native population there has been killed. But I think there isn't any, there aren't any conflicts there as far as I know, at least. For the TNT, of course, this is a very big issue. And I'm not really deep enough into this, I have to say, to give a really informed answer there. I see the challenges from both sides, and yeah, I don't feel competent enough to comment on that particular issue, I have to say.
Okay, that's fair. Thanks for thinking about it.
Hannah?
I think Eamon was first. He messaged in the chat saying before me that he had a question.
Oh, sorry, I was just looking at the hands. Oh, okay, go ahead then, Eamon. You have plenty of time.
Cheers, Hannah. Thanks, Dan. No, I was just wondering, you had one, it was a carbon breakdown in one of your slides, and there was a big section of it which was purchases. And that kind of, I didn't know how the carbon assessment would have been done on those purchases, because it seemed like a really big chunk of the thing, which isn't usually considered in these things, or maybe I just missed them. It's 30%.
Yeah. To be honest, I'm also not 100% sure how that is computed. I think it is essentially computed in the same way as they did it for this carbon audit. That is, they essentially do this audit for the upstream company, and they look at how much products and energy and transport and so on does the producing company use to produce, let's say, a server or a hard disk or a piece of optics or whatever ESO is using. And then you can assign to, I think it's called life cycle product assessment. You can assign a carbon footprint to an iPhone, for example. And then Apple actually does this. You can look it up at their webpage. They do this actually quite extensively to say, okay, this is how much energy is used for producing, let's say, the raw materials that partly from recycling, partly from mining, that are going into the product. How much energy is used for developing the product. So that includes flights by the developing engineers who are flying around, by actually building it, and then how much is used in the actual life of the product, so in terms of energy, but that might be actually scope 1 and 2 here. So I think it's this kind of analysis that has to happen for the upstream companies, and then you can assign a certain CO2 emission value to things like IT equipment or maintenance equipment.
Oh, okay, thanks. Yeah, clears it up a bit. All right.
But I would recommend to go to this webpage, carbon4.com. That's the company that did this assessment. And they have a big method section of how they do all of this. So it's the one thing I take away from this is it's really complicated if you want to go into detail, because of course they cannot do this whole analysis for every upstream company. That would be way too much. But ESO orders stuff from all sorts of companies. And this company, the Carbon4 company, who did the carbon audit, cannot audit all the other upstream companies. So they need to have some, let's say, average values for the industry of how much CO2 does the hard drive need to be produced on these things.
Yeah, it'll be very difficult to do for the new robotic telescope anyway, to figure this out properly, if we want to do something like this. But yeah, thanks very much. I'll look at the website for sure.
Hannah?
So this is more of a comment on the previous discussion about outreach. And I would just say that it's really important to make clear that we're not experts on climate change, but that even though we are scientists, we do understand the methodology. We do kind of believe that this is real science. It comes from lots of different independent sources. And so I think as long, and I think the public appreciate that honesty as well. And so, and they do respect, you know, they do want to learn about science and they have an appetite for it. And one really good way of engaging the public is really kind of by using storytelling, by saying a bit more about who you are, why you're doing what you do. And this also works for just giving astronomy talks, not just for, you know, giving stuff about more difficult topics like climate change. So yeah, there's just really a real power of, if you just kind of say, if you were giving a public talk about this, being honest that you are not an expert, but you believe in the, well, believe is the wrong word, the science is there. Yeah, I think that's all I've got to say.
Yeah, thanks, Hannah. These are really good statements. I fully agree. I mean, we should say upfront that we're not climate scientists and say that we're reporting about this. But I think what we can also say is that, I mean, we are scientists, and many of the things that go into the results from climate science, like these proxy studies, they are actually relatively straightforward physical relations that we can understand. I mean, a lot of assessing or a lot of producing these climate models has to do with relative transfer, where actually some of us are experts in. So there are certain aspects where we can actually at least understand very well how these models are built up, how proxies are used, and I think that we can use that and then simply explain it. I mean, I've given outreach talks on exoplanets, which is not my expertise, right? I'm studying AGNs, and nevertheless I can read their papers and report about them, and I think that's fair enough to do. Your second point on storytelling is also a very important one, and actually the not being expert goes actually one level further. We're not only not experts on climate, but we're also not experts on climate communication, which is a very different thing by itself. And some people have said that in climate communication, you can actually do things very wrongly, and by that way hurt your cause more than you actually help. For example, there have been surveys of people asking whether they know about the climate crisis and that it's caused by humans. And it shows that many people actually know this in their cognitive brain, but they still don't act accordingly. So adding more to the knowledge, like showing lots of graphs, and like I did, okay, but then you're all scientists, but doing this to the general public might sometimes not help. But indeed, the storytelling that you mentioned, Hannah, is a much stronger way, a much better way to connect and to saying directly, how does the climate crisis affect you and your children and your direct environment, not, you know, the polar bears in Greenland, but or on the North Pole, but how does it really affect Manchester? So I think that's a really good a good connection to make.
So I have a question myself as well, which is about our role in communicating to governments. Because as you pointed out, individual action or even collective action on the part of departments and large companies and everything can only do so much. And really the only way to produce the kind of dramatic reductions that you showed in your plots, absent some sort of unexpected technological revolution, is really large scale changes to government policy and carbon taxes and similar things like that. And so how do you see our role in pointing out the government the urgent need for these sorts of things without sort of endangering our perspective as sort of neutral, external, impartial observers to policy?
Yeah, that's a tricky question or a difficult question. I think First of all, I don't think we should see ourselves, I don't think we can see ourselves as neutral scientists in this crisis. I mean, it's too much is at stake to say, oh, I'm neutral, you know, I'm just observing redshift 2 galaxies. I don't care what's happening on Earth. I think that's a standpoint that, yeah, you can have, but then essentially you're allowing everything to continue. So I think it's important to say, as scientists, at least I really believe that we are allowed, we should have our own opinion on political matters. Like you mentioned the carbon tax, I think we're allowed to have our opinion and say, yes, we need that, and we need it very quickly. We shouldn't just say, oh no, because I'm a scientist, I have to be neutral and I cannot say anything. One way to weigh in your scientific weight to the political debate is by joining climate rallies. I've been doing this a couple of times, and then together with colleagues, and sometimes we make signs that say, I don't know, I'm a scientist, there is really no planet B, or something like this, to give your scientific credentials and say, you know, you support their statements, and you kind of give perhaps a little bit more weight to some of the demands. And of course, you can get in direct touch with politicians. I mean, on the local level, on the regional, national level, just write to your politicians. That actually is many politicians are actually way more accessible than people believe, especially on Twitter, but also via email or just telephone. You can really call them and say, hey, I'm really worried about this. What do you actually do? And if enough people are doing this, if you say, hey, I'm a scientist, I read the literature myself, I know what's at stake. So how do you react to that? So I think you can have an informed discussion, and you can bring in your own scientific knowledge and expertise, and perhaps explain to politicians why these things are very important.
Great, thanks. Okay, so we're at the hour, so we should wrap up pretty soon. There's a couple more hands up, so I'll let Violetta speak first, and then Trisha, and then we'll conclude the discussion. But I'm sure Leo will be happy to take discussion offline for those who really want to follow up. So Violetta, go ahead.
Hi, just following up on what you said about bringing the problem closer to home. The problem that I find myself in is it's a bit difficult to say what is the effect right now in Liverpool. You can say like Liverpool is next to the sea, and in some years it might be flooded or whatever, but do you have any kind of recommendation or material, whatever, that the perception of people might be like the winters are milder right now, but I don't think that that's appealing to this is a real problem right now.
Well, I don't know the climate of, sorry, you wanted to say something?
Oh, I was going to jump in and said, just before this discussion, I got an email from the water utility saying, please cut your water consumption. We're entering a shortage possibility. So that's a very real thing that impacts our lives.
Yeah, that's actually one thing I would also have mentioned. That's certainly the case in the Netherlands, that the last couple of years have all been drier than the most extreme dry year, which was in 1970s or so. So droughts are one thing. Sea level rise might actually happen faster than people think. If there are these reports from big ice shelves being cut off the Antarctic. So sea level rise is an issue at some point, especially for the Netherlands, but also for other coastal regions. There's also you mentioned the warmer winters, possibly mosquitoes that are not endemic, but might come and also convey some illnesses that we're not used to in the north. There's due to droughts and perhaps more storms, and so you can have problems with harvests. Actually, some people predict that the total harvest of grains and all sorts of vegetables that we produce will go down in a more extreme climate. So these are all things that are perhaps on a too long timescale to connect to real people. But I think if you connect it to timescales of someone's children or someone's grandchildren, and say, look, they will have to deal with this, then perhaps it becomes a bit more real.
Okay, Trisha, I saw you put your hand down. Did you have a comment?
Well, we're running out of time, but all I was going to say was that in terms of scientists being involved in political issues, I think that the coronavirus situation that we've seen unfolding here in the UK, and also to a degree in the US where I'm from, it's a dodgy business because there are bad faith actors and there's a strong anti-science pushback as well. And it seems to me that this is a really tricky business, but it's another conversation probably.
I mean, I'm not quite sure what you're referring to. There have been some, some scientists who were not experts who made all sorts of claims on epidemiology, for example, which clearly they shouldn't have made.
I think what I meant in the UK was that our government said, oh, well, we're following the science, but it turned out that they really weren't. Yeah,
but I think, to me, what the corona crisis mostly showed that those countries that followed the actual best scientific advice, so mostly the World Health Organization suggestions, they actually did best. And people who followed fringe opinions, like unfortunately the UK and also Sweden, and to some degree, at least in the beginnings, also the Netherlands, of herd immunity and these things, which have never been proven, or which were more or less clear that they're too dangerous for this pandemic, they are doing not so well. So I think the corona crisis is actually showing us that yes, science can be quite complicated, especially if there's something very new, but following scientific advice does actually help and actually saves lives.
Okay, well, why don't we stop there? Thanks again, Leo, for this, and thanks everybody for joining. Yeah, I'll stop the recording and do the clapping reaction. And yeah, thanks again.
Thank you, everyone, for a very good discussion as well.
Great.
And yeah, be in touch if you want to discuss more. You can find me on the Leiden website or just Google my name. You'll find me.